really going to consolidate the stuff we've been doing on sine. So perhaps our very first lesson there with the sine graph may have been like a little bit confusing. Our second lesson, hopefully we're feeling a bit more confident about, because we're going to take it a bit further, just because that's what cos does. And we're going to see the similarity between them. Firstly, we're familiar with that graph, okay, that's what we've been dealing with. But now we're talking about the cosine function, which looks like this. We did the graph of it on the back of the sine page. We've done both already. They're the exact same function, except if you take this one and move it that way, pi on 2 units, or 90 degrees, horizontal translation, okay, if we move that point to there, then you get the exact same wave between 0 and 2 pi. And so that means cos of, sine of theta plus pi on 2. Okay, we're moving the sine wave 90 degrees that way is equal to cos of theta. All right, horizontal translation. And the other way is that cos of theta take pi on 2 is sine theta. Okay, in that if you're to move this one, pi on 2 units, okay, then that point is now going to be at pi on 2, which is the sine function. So we're going to use this one, and we're going to use this one to answer these two questions. Here's the first one. Graph y equals 2 cos of x on 2 plus 3. Okay, firstly what we want to do is identify the values of a, b, c, and d. So I'm going to express this, the very first thing I'm going to do is express this like this. Half x plus 3, and then we can very clearly see what the value of b is. Right? Whenever there's a fraction, bring that number out front. And so we've got a is 2, b is half, c is 0, and d is 3. Okay, here's the general cosine function, exact same as the general sine function. Okay, amplitude of 2, vertical translation of 3. Okay, so when we're sketching these, a good way to start is draw our axes, and we've got a vertical displacement of 3, so that means we're up 3 units. That's the principal axis, and you can draw a dotted line there if you like. That's the equation of that line is y equals 3. That's our principal axis. And we have an amplitude of 2, so that means we're going up 2 units, 5, and down 2 units, 1. So that's going to be the peaks, and that's going to be the troughs. Now, cosine starts at the top. Okay, so this is going to be our starting point. All right, so that's the difference. Normally sine, when we've drawn sine, we've seen that sine starts on the principal axis. Cosine starts right at the top. And then the other thing we need to consider is how many wavelengths there are. So we've got half here, b is half. So we've got half a wavelength in 2 pi, just like sine. Remember, the value of b tells you how many wavelengths there are in 2 pi. So that means there's a full, if there's half a wavelength in 2 pi, a full wavelength in 4 pi. All right. And cos is reasonably easy to draw. I think sine's the easiest because you just like peak trough. But cos, what we're doing is we start with the top point, we're just going down and then back up. Okay, so we should finish there. All right, so just sort of plot those points. At 2 pi, that's going to be half a wavelength. And then at 4 pi, that's going to be our whole wavelength. So it's coming down like this, yep, to the minimum, and then coming up like this. So there's a maximum there. So yeah, it is a bit harder to draw. All right, what we've got is clearly this is this is why it was difficult to draw. The lowest point is 1, not the x-axis, and that's the lowest point, and 5 is the highest point. Now clearly, we've got a whole wave here. We've got a whole trough there. See how that's a whole minimum? And then we've got half the max here and half the max over here. So we have half the max plus half max. We've got a whole peak as well. So that's my thinking behind that. Again, use your calculator to support you. So, identify these values. We should understand the effect that they're having. 2 is the amplitude. That's the distance from the principal axis to a peak or trough. Our principal axis was 3, so our peak is at 3 plus 2, 5. Our trough is at 3 take 2, so 1. And then this value b. How many wavelengths in 2 pi? We have half a wavelength in 2 pi. If you go on to that point there, that's only half of a wavelength. You can see it's half a peak and half a trough, half a wavelength. Over here we've got another half a trough and another half a peak. That equals 1 whole wavelength. Okay, question 2. Find, so now we're doing the opposite. We're starting with a graph and we need to find the equation of it. So, we should identify the principal axes first. That's always what to start with. So we want to say what's our values of A, B, C, and D. And we've got D is always halfway between the peak and trough, or the maximum and minimum points. So between 3 and 1, I've got D is positive 2. Okay? So if D is 2, if that's 2, then the amplitude is just 1. Okay? Our amplitude hasn't changed here. We don't have any horizontal translation because we're starting at the maximum point again. So C is 0. And then B, this one's going to be a little bit tricky. Okay? What we can see is we've got one wavelength to there. Okay? Half a peak, a whole trough, and then another half a peak. So that's one wavelength. And then we have another wavelength to there. Okay? Again, half a peak, a whole trough, and another half a peak. So we have 2 wavelengths in pi. How many wavelengths do we have in 2 pi? 4, okay? We have 4 wavelengths in 2 pi. So therefore our value of b is 4. And so the equation of this function then would be 1 cos 4x plus 2. And this one out front is obsolete. We do not need to write that. Cos 4x plus 2. Splendid. So that's the exercise we're doing today. That is 7c, the cosine function.